Yeah, we can hear.
So are there any questions before we continue with motions in space? Okay, so yeah.
Professor, so in the homework, in the learning curve, there are, for the curvature, there are many equations. So for the quiz, do we only use the one that is like r prime cross r double prime over the magnitude of r prime cubed?
Yeah. In general, you can only use like that equation will it's a generalization of all the other equations. So if you know that one, you can use it in any case. So yeah, you only have to really memorize that one.
Okay, thank you.
Okay. So we're going to continue today with motions in space. And 1 second. Okay. And the first thing is that the velocity of a particle, if we have an object, so here we're in space, and here's our curve. So imagine a particle moving along this curve, and we can take a look at so this over here is r of t, and this would be r prime of t, and this would be equal to the velocity, or at least the magnitude of this is the speed. So, second. Okay, so again, so the velocity over here is going to be equal to r prime of t. Or at least you could look at the magnitude to know your actual speed. And the acceleration is going to be r double prime at a given point. So now they want calculate and plot the velocity and acceleration at t equals 1 for r of t is equal to sine of t, negative cosine of t, and the square root of t plus 1. So we have r of t is going to be equal to sine of 2t negative cosine of 2t and the square root of t plus 1. So this would look like a helix. This over here, the sine and the cosine, as usual, they make this circle, and this is increasing. It's the square root of t plus 1. If t is very negative, then this thing is not defined, so the helix would stop there, but for a while at least, the helix goes. And then we want to find the acceleration and the velocity, or we want to find the acceleration and velocity vectors. So those would be this. The magnitude of this would be the acceleration at the speed t is equal to 1. So for t is equal to 1. So first, r prime of t is going to be equal to 2 cosine of 2t. And then we're going to have 2 sine of 2t. And from here, we're going to have So that would be t plus 1 to the 1/2. So the derivative is going to be 1/2 t plus 1 to the negative 1/2. That would be equal to 1 over 2 square root of t plus 1. So this is 1 over 2 square root of t plus 1. So this would be our velocity vector. And so this 1 is going to be equal to 2 cosine of 2, 2 sine of 2, and 1 over 2 square root of 2. So far, let's see. Yep. Okay. And so then when we look for the acceleration, we're going to take the derivative again. So this is equal to the velocity vector. And this is equal to the velocity vector at 1. And so then the acceleration vector is going to be 4 negative sine of 2t, 4 cosine of 2t, and so then this over here is going to be 1/2 times t plus 1 to the negative 1/2. So the derivative is going to be negative 1 over 4 square root, and then t plus 1, and then 1/2 minus 1, which would be negative 3 over 2. So that would go here. So we would get negative 1 over 4 t plus 1, negative 3 over 2. So that's going to give us the acceleration vector. And then the acceleration vector at t1 for t equal to 1 is going to be negative 4 sine of 2, 4 cosine of 2, and negative 1 over 4 times 2, negative 3 over 2. Any questions about this? Okay, so now if we want to calculate the speed, we can just take the magnitude of v1 and we would get the speed. So this is going one way, and it's the easiest way. If you have the position, if you have the curve that tells you the position of your particle, it's pretty easy to find the velocity, pretty easy to find the acceleration. And we can also go the other way around. If you have your acceleration, you can take the antiderivatives to find the velocity and the position. There will be some constants that you're going to have to deal with. So we have to know some initial conditions, but overall, it's not such a big deal. So let's look at that. So if an object is accelerating, so we can say that the velocity is going to be the antiderivative of the acceleration, and the position is going to be the antiderivative of the velocity. So let's look at an example. They want us to find r of t if the acceleration is this, and this is one condition, and this is another condition. So let's see what happens. So our acceleration, we have a of t is going to be equal to cosine of t e to the t and t. And we have that our r v0 is I and r0 is k. So v0 is equal to I and r0 is equal to k. Okay, so now the velocity is going to be equal to the antiderivative of the acceleration. So that would be, so this over here is going to turn into sine of t plus some constant 1. And then this over here is just going to be e to the t plus some constant 2. And this over here is going to be t squared over 2 plus some constant 3. Now looking at V0, so V0 from this perspective, when we plug in a 0 over here, we're going to get C1. When we plug it in over here, we're going to get 1 plus C2. And we plug it in over here, we're going to get C3. And we know that this is equal to I. So this is equal to the vector 1, 0, 0. So that tells me that C1 is equal to 1. C2 plus 1 is equal to 0. And C3 is equal to 0. And so from here we get C2 is equal to negative 1. So C1 is equal to 1. C1 is equal to 1, C2 is equal to negative 1, and C3 is equal to 0. So let's plug that in to our velocity. So that would be V of t is going to be equal to sine of t plus 1 e to the t minus 1 and t squared over 2, and that's that. So now our position, r of t, is going to be the antiderivative of this, so that's going to be equal to negative cosine of t plus t plus c1. And then this is going to give us e to the t minus t plus c2. And this is going to give us t cubed over 6 plus c3. So far, is this clear? Well,
yeah, it's clear.
Thanks. So now r of 0 is going to be equal. So this over here is going to be negative 1, and this is 0 plus c1. And this over here is going to be 1 plus c2. And this over here is going to be c3. That's equal to k. So that would be equal to k from this over here. So can you see this hand, by the way? When I move this hand around, can you see it?
Are you talking about the white hand?
Yeah.
Yeah.
Okay. So this thing is going to be equal to 0, 0, 1. So that would tell us that negative 1 plus c1 is equal to 0. 1 plus c2 is equal to 0. And c3 is equal to 1. So this tells us c1 is equal to 1. C2 is equal to negative 1. C3 is equal to 1. So now let's plug that back into this. So we get my r of t is going to be equal to negative cosine of t plus t plus 1. E to the t minus t minus 1. And t cubed over 6 plus 1. So that's correct. So r of t is negative cosine of t plus 1 e to the t minus 1 minus 1, and t cubed over 6 plus 1. So that would be our r of t. Now, if you wanted to figure out now what a particle will be at time 1, for example, you can just plug that in at this point. So they might ask you, okay, what is r of 1 then? And you can plug it in and say, okay, that would be negative cosine of 1 plus 2, and e to the 1 minus 2, and 1 over 6 plus 1. And then, yeah. Okay, so now they tell us that near the surface of the Earth, gravity imparts an acceleration of approximately, so generally if we're standing like in a building and we throw an object, this object will fall with a certain acceleration. Even if it were just sitting here, it would be, it would feel, you would have pressure, and that would be some type of acceleration, some force, and force is related to acceleration. And the acceleration is 9.8 meters per second in the downwards direction. So if we have a projectile moving near the surface of Earth that has no additional means of acquiring acceleration, we know that its acceleration vector is determined by gravity. So we can figure out what AFT is. That's basically what they're telling us. If you have a projectile, you know that your AFT is negative 0.68 meters per second. And, well, 1 second. Oh, and this is just in 2 coordinates. So now you have two coordinates for them. So it would be in your y. So here's your x, here's your y, so it would be your j. So your AFT equal to 0 and negative 9.8. So now they ask us to use this information, and they say a projectile is launched from the ground at an angle, a certain angle with speed 100 feet per second. Show that the projectile lands at a distance of 625 sine, cosine feet. Okay, not sure. Okay, 1 second. From the launching point. This is So let me see if that sine cosine thing is a mistake. 1 second. Oh, no. Okay. Fine. So the way to do this is by setting up the acceleration vector. Okay, so first our acceleration, like we said, is going to be 0, and I think they're going to use negative. They're going to use this, the feet. So I'm just going to do that. So negative 32. Okay. Now your velocity, we know the speed of this thing. It has an x component and it has a y component. So they tell us, they tell us that it's going to be thrown at a speed of 100 feet per second, which means in the x coordinate, we remember x is equal to r cosine of theta, and y is equal to r sine of theta. So in the x coordinate, we would get 100 times cosine. And in the y coordinate, we're going to get 100 times sine. So let's just rewrite some of this. So our acceleration is going to be 0 and 32, negative 32. And our velocity at time 0 is going to be 100 cosine of the angle at which we throw this thing, 100 sine at which we throw this thing. right? So we're standing over here on the ground. We throw it with a certain velocity. There's the y component of the velocity. There's the x component of the velocity. So this over here is the 100 cosine of the angle. And this over here is the 100 sine of the angle. So now we also know that at R0, at time 0 at the ground, so we would be at 0, 0. And that's what we have so far. So the question is, can we use this to figure out what R of t is going to be? And so let's do it. So first, let's take the anti-derivative of our acceleration. So we have that v of t is going to be equal to some constant c1, and then negative 32 t plus some constant c2. And so for v of 0, we have that this is going to be c1 comma c2. So now we know that c1 is equal to 100 cosine of theta, and c2 is equal to 100 sine theta. So we can plug it in. So we get v of t is going to be equal to 100 cosine theta negative 32 t plus 100 sine theta. So now looking at R of t, we have that this is going to be equal to 100 cosine theta times t plus c1. Then we're going to have negative 32 t squared over 2 plus 100 sine theta t plus c2. So now R of 0 is going to be equal to, so looking at this side over here, this is going to be 0. So we would get c1. And on the second side, this is 0 and this is 0, so we're going to get c2. And we know that this is equal to 0, 0. So that means here c1 and c2 is equal to 0, 0. So that would tell us that our R of t is going to be equal to 100 cosine of t, angle of t, negative 32 t squared over 2 plus 100 sine the angle of t. Okay. So now so what else do they want? Show that the projectile lands at a distance of that from the launch. Okay, so where does this, so now that we have what R of t is, the question is, where does this projectile land? So the distance is here. The t that we would be looking for is here. So we're looking for when this is equal to 0, that would give us 2 t's. One of them will be where the projectile lands. We can plug it back into this t. and that would get us the solution. Although, okay, 1 second, let me. Let's see. Was launched at this t. So then they plug that in. It's equal to that distance from the launching point, and then they plug that into t. Okay. So yeah. So they tell us that okay. So they tell us that so let's set this thing equal to 0. So negative 32 over 2 t squared. So I can take out a t, and I can take out a t from here and assume that they're not 0, because whatever, plus 100 sine of this angle is going to be equal to 0. So now we're going to get the t is going to be equal to negative 100 sine of the angle. Okay, the negative cancel with that negative over 30 over 19. Okay, and now we can plug that back into here to find the position. So we will get 100 cosine of the angle times 100 sine of the angle over 19. Okay. Any questions about this? Oh, 16, sorry. Okay. Any questions about this?
I had a question. Will we have a quiz review today, or would there be like a, or should we look at like the sample exam packets online?
Well, the quiz, the examples for the second exam posted? I don't think so. The quiz is going to be similar to those problems, but it's going to have new information from the stuff that we just learned. So let's go here for a second. I'm not going to review for the quiz, but starting from quadratic surfaces, you need to know the basic quadratic surfaces and how to figure out what they are. Vector functions, I mean, it's fairly basic at this point to know what vector functions are, which are what we've been using until now, and what the calculus of them are, how to take the derivative, how to find the velocity, stuff like that. And then over here we have the arc length and speed, which arc length you use Pythagoras' theorem for. So yeah, you should be able to know how to do that and how to reparameterize a curve so that the speed is 1. And for curvature, you need to know the main formula for curvature, and then you need to know what the normal vector is and the binormal and the tangent, the unit tangent vector are. So you need to know how to do that. And that's it. That's where the quiz is up to. So this section will not be on the quiz, and then next week we will review for the exam and have the exam.
Okay, thank you.
For arc length parameterization, is that the one that like the first one we have speed 5 and then we want the speed to be 1?
Yeah.
Okay. And for quadratic surfaces, is it like enough just to know the equations for each shape?
Yeah, so know that, and also be able to trace out some things from the basic shape. So like if, let's say you're dealing with a cone, be able to show that it's a cone by like setting x is equal to 0 and seeing certain things, setting y is equal to 0, seeing certain things. So be able to like trace out different parts of the surface. So ellipses, you should be able to trace out different circles and stuff. For cones, you should also be able to trace out different circles and things like that. Okay.
Okay, thank you.
Oh, I had one more question. How long is the quiz? How long do we have to take the quiz tomorrow?
3 hours.
3
But-
hours?
Yeah.
Will it be the same like last time, like the same amount of questions and everything?
Yeah.
Okay.
Any other questions?
Do you have a sample questions like posted?
No, I did not write out sample questions for the quiz. The quiz is to some degree to review for the exams. So, but the questions will be very similar to what you find in the textbook. So just go over. There won't be a question that's too complicated. I gave one example. I can give a few other, but one of the examples that I gave last time, was if you have two curves, you should be able to find the angle between them for this angle. So that's like an example of what you would need to do. You need to figure out, take the tangent vectors and then find the angle between them. So that's an example of a problem that can appear. I can ask you to find the velocity of a particle at some point, or things like that. Nothing too difficult. Okay.
So we can take our quiz anytime we want, right? I mean,
Yeah.
there's okay. Yeah. Thank you.
Other questions? Okay, so let's continue. So now we want to move on to another important shape that we can discuss its velocity, acceleration, position. So if you're in a particle moving on this circle, they want us to find the acceleration for the motion of the particle around the circle with radius r and constant speed v. So in order to do this, we just need to know what the equation of this circle is going to be. So our r of t, one second. R of t in this case, well, a good equation for a circle always is going to be some radius r, because that's this radius. And then you're going to have cosine of the angle and sine of the angle. Sine of some angle, because that, sorry, and yeah, okay. Okay. So we have, sorry, let me do this here. We would have that r of t is going to be equal to r cosine, and it doesn't matter what speed we're running through this thing, so there would be some, okay, let's say omega of t and sine omega of t. So now when we look at the velocity, we just have to take the derivative. So this is going to be r. And then over here, we're going to have omega negative sine of omega t. And omega cosine t. And then the acceleration, so this is r prime of t. And then our acceleration is going to be equal to r omega negative cosine. So now we have omega squared omega t, and again omega squared negative sine of omega t. So this is our acceleration vector. So what else did they want? Oh, and they want the magnitude of this thing. So the magnitude of this, FAT, so that's going to be equal to, so here we're going, so we can think about putting the r inside. We take the square of these two things. This and this squared is going to be 1. So we're going to get r squared omega to the 4th, maybe, I think. Let me see. Oh, sorry, because there's a square root. Sorry. So that's just r omega squared. Okay. Any questions about this? Okay. So, as usual, the acceleration vector, they just tell you it can be broken off into the tangent part and the normal part. So when we have a curve and we have the acceleration vector, we can have the tangent component of that acceleration vector and the normal component of that acceleration vector. And these are the formulas for them. Well, in order to find the tangent component, we need to project the acceleration onto the velocity. And in order to find the normal component, we are going to find the tangent component and then take the acceleration vector minus tangential vector. I actually don't really think that it's very important to know how to decompose the acceleration vector into two different vectors. So I'm gonna skip it. I don't think it's gonna appear in the test. I'll definitely make sure. But for now, let's assume that we don't have to worry about it. So the main things about this section are how to find velocity, how to find acceleration, using the derivatives and using the antiderivatives. And for now, we're gonna ignore this stuff. But if we need to, we'll come back to it. Okay, so I think we're gonna end this section here. Are there any questions about what we just talked about, or? No? Okay, then have a nice day. And I'll post the quiz tomorrow. I'll try to do it pretty early. So best of luck with that.